All right, so in this lesson, you're given the zeros, and you have to write the polynomial that has those zeros. So let's do this together to begin with. So 1, 2, and 5. So step 1 is, we need to write an actual function, meaning that I have to write f at x equals or y equals or g at x. I need to write it as a function, not just as parentheses. So I'm going to use faithful f at x. You could also use y equals. That would both be good. But you can't just start without that. It's a function. We need that to begin with. Then, and I know you can do this, if positive 1 is a 0, what's its factor? If positive 2 is a 0, and if positive 5 is a 0, right? Our next skill is, do you have the skill to multiply that out without a calculator? So we're going to do it together. Now, this might be foiling. I don't know if you did first outer inner last. Some people draw a box, and they set it up. If it's simple, I really want you to get to work on your mental math abilities to do it, okay? So, we're together, so we can do that. So I know x times x is x squared. Can you add the numbers you see? Say yes. That's negative 3x. And then negative 1 times negative 2 is 2. See, if it's a simple trinomial, is there really any reason to draw a box there? I want you to be efficient. I don't want you to take too much time. Sometimes time matters. Now, do you know how to multiply a trinomial and a binomial? Now, again, we can draw a box, or we can FOIL. Are you more comfortable with foiling, or more comfortable drawing a box and filling it out? All right, I'll humor. So I'm going to draw a box. Now, if I'm going to draw a box, what size of box am I going to draw? So that's a sideways one. I mean, it could be vertical too, but it has to be 2 by 3 somehow, right? 2 terms, 3 terms. Yeah. So the trinomial is going to go on top, and the binomial is going to go underneath. And then we need to multiply and combine like terms. Remember to add the exponents. This is x and negative 10. So we can now have our answer. So the power term is x cubed. Can you combine the quadratic terms? And you get negative 8. Can you combine the linear terms? And you get 17. And then the constant is 10. That's the skill for this lesson. Can you set up, if I give you the zeros, can you show me the factors? And then can you multiply the factors out? Let's try number 2. Just because I'm going to use a different letter. G at x. So first the setup. Can you write this as linear factors? So if negative 7 is a 0, then it's x plus 7. If negative 1, then it's x plus, and positive 3 is. Now I'm asking you that if it's simple, like for binomial times a binomial, then we're just going to go x squared. Can you add 7 and 1? Can you go 7 times 1? Is that okay without drawing a box? So if you need to, we can draw a box again. This is called distributing, mathematically, what we're doing. So right now we are distributing. So we found the power term to be x cubed. And then we're finding the quadratic terms. We're finding the linear terms and the constant. So the last step is combining like terms. Be careful here. Easy peasy, right? We good? We good?
Yes.
I like that. Just because I'm going to write h at x. I just want to show you that you could have different examples, different letters to represent functions, but you can't. You got to write it as a function. Now I'm going to go to the fun number right away. Can I do that? So what's the fun zero that I'm looking at? Do you know how to write that as a linear factor and not write it as a fraction? So what do we do? So the denominator becomes the lead, right? The denominator. And then the numerator, we're going to do the inverse. So in this case, we're going to add 4, right? And you can double check how. Like subtract 4 and divide by 3, right? You can go back and forth. The other two are, I hope, simple. So one's x plus 2 and one's x minus 2. All right, do the next step. Avoid 3x plus 4. Let's do the, remember you can multiply in any order. So I'm going to save 3x plus 4 for the end. So x plus 2x subtract 2. It's also called the difference of squares. Do you know how to multiply out a difference of squares? So I'm going to challenge you without a box. You ready? 3x times x squared is 3x cubed. 4 times x squared is 4x squared. 3x times negative 4. And 3x and 4 times negative 4. And you have it. All right, let's practice number 4. Anytime I can challenge you to do something mentally, it's important. Can you set up number 4? Just because I'm going to write y equals so that you understand different ways to write a function. Okay? Let's not feel confused by this. If it's not a fraction, we're just going to use the number, okay? And change the sign. So positive becomes negative, negative becomes positive, and the last one would be x subtract 1. I know it doesn't look it, but this is a difference of squares. So x times x is x squared, and negative times a positive. Do you know what root 2 times root 2 is? Just 2. All right, again, I'm going to challenge you. Can you multiply it out? Thank you, Rosa. Rosie? Rosalva. I know, it's all wrong, right? Thank you, Rosie. Does no one call you Rosa? No Rosalva, no Rosa. Always your personality. Rosie. This is x cubed. It is also subtract x squared, subtract 2x plus 2. So in the past, this is what you were given, and then what did you find? The zeros. Now you're given the zeros. Can you write a polynomial on it? So you try number 5. is the first step basic. Are you able to see a difference of squares here? The question, though, is, do you know how to go 2 root 3 times, like, do you know how to multiply those together? Can I help you? So 2 times 2 is, and root 3 times root 3 is, so altogether it's x squared subtract 12. In the second one, x minus 1, x plus 1 is x squared minus. And again, this is a fairly basic one to multiply out. X squared is x to the 4th. Add the numbers and you get negative 13x squared. Multiply and you get positive 12. The next one is going to be cumbersome. All right, number 6. This is going to feel a little bit cumbersome. So negative 6 becomes x plus 6. Now, I'm not going to make the mistake I made before. It's x subtract and then use parentheses. X subtract and then use parentheses. Why didn't I do what for number 5? Why didn't I use extra parentheses? Because it wasn't a binomial number. Like, it was only one number, 2 root 3. Here we have 2 and root 5. Like, we have 2 separate numbers adding or subtracting. A rational number and irrational. 2 root 3 is just one irrational number. Okay? All right, you ready to follow this? So I'm going to leave x plus 6 alone right now. And what I'm going to do is I'm going to have the ability to multiply this out. So in order to do that, I'm first going to distribute the negative. So the second parentheses I'm going to get rid of. So I'm going to go subtract 2 and then subtract root 5. And here is going to be subtract 2 plus root 5. A box is going to be helpful here. So it's a 3 by 3. Make sure I have enough room here. So we're going to multiply this out and then combine like terms. This is as cumbersome as it gets. All right, so it's going to look better soon. I promise. So once you multiply it out, we're going to combine like terms inside the box. What happened? Which ones? In the box, one's plus and one should be minus, right? What? You're right. This should be minus. which will change this to negative, this to. So minus and a minus is plus, plus and a minus is minus. All right, let's double check to make sure that we're okay. There will be things we'll cross out soon. This one does not have an x, does it? Just negative 2 root 5 and negative 5. So we have 1x squared. So I'm going to write down x squared. Do you see negative 2x and negative 2x? That makes negative 4x. Now some things should start crossing out. Do you see negative x root 5? It crosses out with positive x root 5. And guess what? They are eliminated. Do you see negative 2 root 5 and positive 2 root 5? They are eliminated. And what's left is 4 take away 5, which is now again you can draw a box or not. We have one more multiplying to do. So I'm just going to FOIL just to save space. So I just went the first times each one and the second times each one. So I just went the first times each one and the second times each one. That's it. Now, when I combine like terms, it's over. So negative 4x squared plus 6x squared is plus 2x squared. Negative x and negative 24x is negative 25x, and then the constant at the end is negative 6. So, if this was your question, how would you go back to find the zeros? You'd have to do rational zero, theorem list. Negative 6 would be your treasure. What's left over, you'd have to complete the square and get your answers, right? So can you go forwards and can you go backwards and forwards and backwards and so on? All right, number 7. We are still writing polynomials and practicing together. For this example, it says 3 is a 0, and what's its multiplicity? So I don't write down just x subtract 3, I write down x subtract 3 squared. And positive 5 becomes x subtract 5. Now, we can't FOIL the two together here. Because of the squaring, order of operations, we have to square first. So do you know how to go x subtract 3 squared? So x squared, yes? What's negative 3 and negative 3? And then negative 3 squared is 9. And then we're going to FOIL again. And if you want to draw a box, you can. So I'm just going to take the first term and then multiply it through. And then take the second one and do the same thing. Then I'm going to combine like terms. This polynomial has a 0 at 3 with a multiplicity of 2 and another 0 at 5. Let's try number 8. So if I give you the zeros, can you tell me the factors? So, do you know what 0 gives you as a factor? Just x. If it had a different multiplicity, we'd have an exponent on there. Positive 1. And to make life easier, 5 divided by 2. Do you know how to write that as a linear factor? The denominator becomes the lead, right? And then we subtract 5. And because we're multiplying it out, we're not going to write it squared, but we're just going to repeat it twice. So I'm going to go x times x and x times negative 1. And I'm going to multiply the last two together. So 2 times 2 is 4x squared. Negative 5 times 2 and negative 5 times 2. That's negative 10 and negative 10, which is negative 20x. And then a negative times a negative is positive 25. Our last step is to distribute and combine like terms. So I'm going to take the x squared and just multiply each term. Oh, make sure I add the exponents right. It's 4x to the 4th minus 20x cubed plus 25x squared. Subtract 4x cubed plus 20x squared. Last one, subtract 25x. All right, last step. So our power term is 4x to the 4th. X cubed, I have a negative 20 and a negative 4. That's negative 24. X squared, I have a 25 and a 20. That's 45. And for x, I just have a negative 25x. All right, turn the page. So, I'm going to let number 9 and number 10. I want you to practice 9 and 10. There won't be a video on 9 and 10, because I'm not going to do it right now in the video. Instead, there's an answer key, right, inside that, and you can check the answer key to see if you did it correctly. Let's quickly look at complex zeros, and then we'll be done our lesson today on knowing how to write polynomials. So first, another theorem called the conjugate root theorem. A conjugate root theorem is if a polynomial has a complex zero, a plus bi, then there must also be another complex zero, a subtract bi. Conjugate means if there's one adding, there has to be one subtracting. Or if there's one subtracting, there has to be one adding. So if there's an I, you have to have the pair that goes with it. That's the conjugate pair theorem. So in other words, you have 5 and 3i. What's the pair that's missing? If you have a positive 3i, you must have a negative 3i. That's the conjugate pair theorem. So if you see an I as one of the zeros, then there must be its partner. And if you don't see it, you add it on, and it's just a different sign. Okay? Now the rest is similar. How do I write this out? So positive 5 becomes 3i and negative 3i. So one's going to be positive and one's going to be negative. Now, we're first going to multiply the complex part together, and we're going to leave the x subtract 5 for the end. So you see a difference of squares, right? One's subtracting, one's adding. So I can go first times first, which is x squared. But the key is this. Do you know how to go last times last? And can I teach you how to multiply that together? So negative 3i times 3i. Do we know how to multiply that together? So negative 3 times 3 is negative 9. And then I times I is I squared. So if I is the square root of negative 1, yes?
Yes.
Then I squared would have to equal, because the square and the square root undo each other, what number are you left with underneath the square root sign? So this is really negative 9 times negative 1. And if you think about it, doesn't it make sense it's x squared plus 9? Because that quadratic factor creates imaginary solutions, right? X squared plus 9. Now finish it. X times x squared, negative 5 times x squared, x times 9, and negative 5 times 9. Done. Number 12. This one has two irrational zeros and a complex zero. Can you tell me which zero is missing that's there because of the conjugate pair theorem? If positive 2i is a zero, then negative 2i is a zero. So the first setup is x subtract root x, or root 6, x plus root 6, x minus 2i, x plus 2i. So we write it as a linear factor. Each zero becomes a factor. So x times x is x squared. This is a difference of squares. So root 6 times root 6 is just 6, but it's going to be a negative 6. The next two, x times x is x squared. Now negative 2 times 2 is negative 4, but do you remember what I squared is again? So it's negative 4 times negative 1, which makes it a plus, and that makes sense. The quadratic factor that's adding gives us imaginary answers. And then the last step to multiply this out. X squared times x squared. Add negative 6 plus 4. And multiply. Number 13. Can you set up number 13? Just because I'm doing a video doesn't mean I can't walk around. That microphone picks up everything. Your little conversation picks up everything. Can you set up the linear factors, right? Do you have the algebra skill to distribute? Be patient, practice. I know you know how to FOIL. This is like the next level, right? In terms of foiling. And if I give you the zeros, that would be rational, irrational, complex, imaginary. You're able to take those zeros, write the linear factors, and distribute. Be patient with yourself. Step number 1. If negative I is a zero, then positive I must be there too. They're partners. That's called a conjugate pair. They always come in pairs. Step 2. And it doesn't matter, as long as you start with something, equals, then it's good. So one's going to be subtracting 2 root 5, and the other's going to be adding 2 root 5. One's going to be adding I, and one's going to be subtracting I. Order doesn't matter. All of these are a difference of squares, which makes it easier to multiply, right? X times x is x squared. The question is, do you know how to multiply 2 root 5 and negative 2 root 5? Are we okay? Are we okay multiplying that? So negative 2 times 2 is And root 5 times root 5 is, so altogether that number is 20. So it's x squared subtract 20. X times x is x squared. I times negative I would be negative I squared, but we know that I squared is negative 1, and a negative times a negative is adding. In your number sense says that better be adding, right? If the answers are imaginary. And then the last step. Can you multiply that out and make it simple? Not long to do, but simple. X to the 4th, negative 20 plus 1 is negative 19x squared. And multiply and you get negative 20. All right, number 14. And this will be the last one for today. So step 1 is there's 1 0 that's there that I have to write down that wasn't given. So if 3 plus I is there, then 3 subtract I has to be with it. They always come in pairs, and those pairs are called conjugate pairs. So can you write the linear factorization of this? And make sure you use a subtract sign. I'm going to combine like terms. You can also do this. No. I'm going to distribute the negative. So I'm going to make it subtract 3 and subtract I, and I'm going to make it subtract 3 and plus I. I'm going to make room for a 3 by 3. Can you do a 3 by 3? Feels like you're going to play tic-tac-toe, right? So now we're going to multiply once it's set up. Why did I say 9 right there? X squared minus 3x, that's 9, plus 3i, xi. There's going to be a lot that should cross out. So there should be a lot that crosses out if I did this right. So I see negative xi and positive xi. I see positive 3i and negative 3i. So now I can combine like terms. So I have an x squared, negative 3 and negative 3 is negative 6. Now this will be a little confusing. We have a 9. The negative I squared is actually a number. I squared is negative 1, and a negative times negative 1 actually makes this positive 1. So the number is actually 10. The last step is to distribute and then combine like terms. So I'll do my best with the space I have. So it's x cubed subtract 6x squared plus 10x, 4x squared, subtract 24x, and then finally 40. So when I combine like terms, hopefully I can fit this in one line. I got x cubed, negative 6 plus 4 is negative 2, 10, And negative 24 is negative 14. And then lastly, we just have 40. Whew. That was some heavy lifting, right? But you guys are strong. All right. That's the end of the lesson in practicing together. So, Mr. G Math, signing off. Over now.